Here we are to review the quiz you did regarding Unit 5 about pressure and substance and properties of matter. And here you can see the questions you did in the quiz sorted by accuracy, meaning how well you did. So if we look at question 12, 27 pupils had it correct and 2 had it incorrect. And if I click on it, I see that there was an accuracy of 93%. So 93% of you did this correct. So what I'm going to do now is review the questions that had the lowest accuracy. I believe we'll do about, let me just go back up. No. Oops. We'll do about 15. I want to go up to the question that has an accuracy, exactly the one that has an accuracy of 59%. I sort of, my threshold is 60%. On average, you did well. Back up. Here, let me see. Up here, game highlights. The class answered 65% of the questions correctly. So that's the class average, which I think is pretty good. Now, the toughest question, longest question, interesting facts. We are going to take a look now, starting at the bottom. I'll try and make this interactive and interesting. So if I ask a question, then pause your video and think about it yourself. So here we see the question that was done the worst, one could say. Perhaps the question was wrong. I can't really see that, what the answer should have been. No, I can in a moment. One moment. So I will see here the average time was taken was 24 seconds. I find that still pretty short for something that is a question you don't, you have never seen before. So the question reads, when you cook shrimps, they turn from gray to pink. Is this process chemical or physical? So somewhere, perhaps we talked about this, you could know that a chemical reaction can be recognized by the change of color, sometimes, and not always, but sometimes. In any case, a substance has an intensive property, that is the color. And if the color changes, the substance changes. And if the substance changes, then it's a chemical reaction. So chemical process, because the color changes, that was given actually away. And the color is a physical property. So 10 players had that right. A lot of you, so I can see, thought it was a physical process. But a physical process, the molecules do not change. So that's, for instance, evaporation of water or melting of ice. Then we move up. And there are 2 questions about the graph. Here I'm really surprised. Average times taken 2 seconds. I don't understand. People, you need to read, think, and then answer. And 2 seconds on average is really far too little. So let's take a look. The graph in the figure above is related to the boiling of a liquid. And we can see that because the temperature increases, goes up. How long does the boiling of the liquid take? So this question basically is to test if you know, whether you know that when a liquid boils, the temperature stays constant, stays stable. So you need to look at the straight line, the horizontal line, and that goes from 5 minutes to 12 minutes. So how many minutes are those? Not 15, as a lot of you thought, because you guys thought from 0 to the end, but only the flat part. So many of you also thought 7 minutes, so well done for you. 3 minutes would be only the last bit, and 5 minutes, the first bit. The other question here about the boiling. This is a bit more difficult. question is, which change of state could also be represented? And that could be, so it's a bit of a trick question, because first of all, you need to read well. And here it says boiling. Now, boiling, answer 4, that was already given. Evaporating is a process that happens during boiling, so it's also not that. Condensing happens when gas becomes liquid, so then the temperature would go down. And so melting is the right answer, because then the temperature also goes up. Not very interactive up to now, sorry about that. Now, there's one more about the graph. Looks like that the graph was a difficult one. Which of the following statements describes what happens between 5 and 12 minutes? So basically, this is a bit the same. The answer is, of course, a phase change takes place, i.e. from liquid to a gas. Here it says nothing happens. That's a bit of a trick one, because yes, the temperature stays the same, but in the meantime, the liquid becomes a gas. A phase change takes place from gas to liquid. No, that the temperature would have to go down, and due to corona, the process went to the shutdown. That is funny. Okay, then the next question here is combustibility, and I explained that means that something burns. Is that an intensive, an extensive property, and a physical or chemical? This one you could know from doing the practical during the project week. And to combust, to burn, is a chemical process, so it's a chemical property, and it's intensive to the substance. So either a substance burns or it doesn't. So here we go. Then we have a question about one of the properties of metal. We studied these in the CLIL activity. Now, many of you knew that it meant that ductile means that something can be pulled without breaking, and others got confused with malleability. It can be formed into a different shape without cracking. Then we have, and it looks like this one you thought about a bit longer. This one is a calculation, and similar to the one you practiced, just with other numbers. So a gas at a volume of 4 liters is at a pressure of 2 Pascal. The volume is changed to 16 liters. What must the new pressure be? Oh, here there is a mistake, as the answer reads atmosphere. This should be at Pascal as well. And so your V1 is 4 liters, your P1 is 2 PA Pascal, V2 is 16 liters, so what is P2? So again, you do P1 times V1 equals P2 times V2, and then you want to calculate P2, so you divide P1 times V1, you divide that by V1. So it's 4 times 2 divided by 16. So that's 8 divided by 16, and you get a half Pascal. So let's take a look what most of you thought. So most of you got 15, and a number of you, yeah, it's pretty even, the mistakes you made. Perhaps some of you didn't have your calculator present, and I should have told you to have that ready. Then a question about solutions that you could have studied in the blue booklet. So what we call iodium in English, Dutch, I mean, iodium, has 2 ingredients, iodine and alcohol. What do we call these 2 substances? And there I wanted you to know what solute and solvent is, and it looks like some people just guessed and got it wrong, and got it the other way around. Then we have this question here, which, oh, here, reads, it's a bit small, I hope you could read it. A thermometer has a graduation which starts at -10 and ends at 110. What is the lower fixed point and what's the upper fixed point of the Celsius scale? So basically that's independent of your thermometer, and it is you could have known this from your practical making your own thermometer, and the fixed points are the melting and the boiling point of water. So I don't have to explain that further. Then we have using the table with which substance is solid at 295 Kelvin. So this is pretty difficult to explain. I refer you back to the blue booklet and the answers, and there we made a sort of a line with solid and liquid and the boiling point and the melting point. So take a look at that and see if you would understand it using that explanation. If not, let me know with an email, and I'll make sure to record a explanation. And are we almost at the last one? So here's another calculation, and you find in your exercises a similar calculation with different numbers. So I refer you to that to know how to do this one. I see that most people got good. We are at an accuracy of 55%. So I think one more question for me to explain. So campers will heat their food above a fire. Explain why, what type of material they will use and why. So they'll use, obviously not something that conducts heat. I think it should have said, explain what type of material they will use for their rod. Metal conducts heat, and then you burn your fingers here. Metal, as it does not conduct heat, that is wrong, because metal does conduct heat. Wood, as it conducts heat, no. Maybe if you've had a campfire, you would use wood. So the only right answer is wood, as it does not conduct heat. And we are still at accuracy 55%. Again, a question about the iodium, and a question about concentration. So it's a new question. But actually it's still a reproduction question. What is meant with solubility? So this you could find in your blue booklets. And then this one. What statement above evaporation of a liquid is correct? So evaporation is the process where a liquid goes into a gas when we heat it. So we add energy. And the answer is the most energetic molecules escape. So the molecules that have the most energy, that they bounce about, and they escape from the surface, and the temperature of the liquid will decrease. So yes, because the average energy, the most energy leaves the space. So the kinetic energy on average becomes lower, and so does the heat energy. And slowly, while heating, it will increase again. And this one might be the last one. Again, a calculation. Again, I'll refer you to the practice questions. And why does sugar dissolve easier in hot tea than in iced tea? So here you can see the hot water causes the water molecules to move faster and the sugar molecules to vibrate faster. So we are talking about the kinetic theory. Therefore, the bonds break up easier and the sugar dissolves. The difference with the other questions is molecules move slower in hot water. No, you should know that by adding heat, or having heat, then they move faster. And here, more space that has got nothing to do with, yeah, it has something to do with heat, but it's about having the energy. So this one has an accuracy of 62%. I'm going to leave it at that. Overall, I recommend you to read properly when you do a quiz like this. Think carefully. Perhaps have some paper next to you to make some notes, and your calculator. If you feel that you could have done better or you can do better now that you've heard this feedback, do the quiz again. I'll post a homework link so you can practice once more. Okay, hope you learned about substances and its properties, and we'll speak again during the lesson. Bye-bye.